Welcome, thank you for coming. My goal today is to try to show you how to do some of the stuff that was shown in the keynote, and the keynote tomorrow as well. I work on our products for developing Docker tools at Microsoft, part of our Azure Developer Experience team. And today we want to learn how to use a mouse. Okay, that's nice. Okay, we'll go this way. Okay, so what I want to do, really? Okay. That's interesting. All right, we're going to find an interesting way to do this. Hold on a second. Slideshow, play from start. And it does not. Oh, wait, I know what it was. We set up the kiosk mode. Setup show. Apologize, guys. Okay, this should do it. There we go. All right. So what I want to do is walk through the container workflow that, as developers, we're trying to figure out how do we deploy this stuff. So it is kind of interesting when you look at Docker that there's a lot of great development tools there. We've talking about with Docker, with Swarm for deploying, but how do you stitch that end to end? And that's part of what I wanted to spend today talking about. So we work in our local development environment, and with tools like Docker for Windows and Docker for Mac, that has made it easier than it's ever been before, so that I can actually develop, but actually develop in a container. Because whether you're working on Windows, targeting Windows, or working on a Mac, targeting Linux, there are still subtle differences in the OS. And certainly if I'm on Windows targeting Linux, there's even more differences. So we want to be able to develop in that container and actually understand what that production environment's going to be. Then when we're done, we're going to commit source code. We don't actually want to commit the image because we have other team members that are committing source. We want to take advantage of the source code control and CI system so that we can actually do a build. And then we're going to use Docker to do a build. And as part of our integration, we'll actually use Compose because we actually want to test our app probably with some other containers to see how they interact. It's kind of interesting to test methods, to kind of get that surface area. But at the end, it's not the API calls that matter inside your app. It's really a matter of the external functionality we want to test. So we want to test it as a collection. We'll run some tests, and assuming the test pass, we can actually push that image up to our registry, probably your private registry, because you probably don't have your code open to the public unless you're a vendor of some sort. And then this is where the interesting brick wall comes in, because we don't want to deploy code. That's one of the benefits of Docker images, is I deploy this binary of an image. And when I deploy it, I'm deploying the image. There's that brick wall of no code. It's the thing that I have tested, which is that image. And I'm just passing it different location-specific information, which is OK in environment variables, and then secrets, which should not be in environment variables, that should be a secret management system. So you can kind of deploy these out to different. So you see the repeat here is I'm taking that same image and deploying it out. So that's a great slide. What was the, oh, what? Oh, I'll show you where the slides are, but you're more than happy to take pictures. But they're all available for download. So that's great, but go from slideware to keynotes, what about in between? So what I want to do today is we're going to build a web front end, an API. I'll do the web in Node and the API in .NET Core. We'll develop it on our Mac with Visual Studio Code, and we'll use Docker for Mac for that local environment. I'm going to use, so you saw them debugging Node this morning, but they kind of just skipped because it's a keynote, right? We want to send the message. Well, how do you get those files in there? So we'll talk about that with YoDocker. We'll push into GitHub, but again, could be any repo. Today we're going to show how Visual Studio Team Services can do that CI and CD of your steps to deploy to the Azure Container Service or Docker Data Center and Docker Swarm. So that was that. So let's go get rid of slides and focus on demos. And now I'm in split screen mode. Ooh, that's ugly. Hold on a second. Where am I? We are going to get out of that and hope it does what, yes, okay, great. All right, so what I have here is I've got, let me just actually go over here. On my GitHub account, I've got these 3 projects that we're going to play with. We've got the web node, the API with .NET, and I have a separate project which we use for deploy, which we'll dig into a little bit later. So if I come over to the console, of course, we can kind of just list this out here, but that's not all that interesting. What I really want to do is edit these. So we're going to use Visual Studio Code. Who's familiar with Visual Studio Code? All right, good kudos there. It's very cool. It's very quick. It's very focused as an editor for editing my projects, my code. I can tell you internally we get into quite big battles of it's great as an editor, but I need to add this functionality. No, you can't do that because we want it to be a lightweight editor. So we have these constant tensions there. So I've got our, it's just a very simple Angular JS app here that I just do in my server. I can see I'm doing a request for index, and then index makes an API call, and I have the ability to repeat it, which is back over here where I'm making this call here. We'll get rid of that breakpoint, actually. So very straightforward. But I don't want to just run it locally. I want to be able to test this in a container environment, because that's ultimately where I'm deploying it. Now, I could go out and read blogs and read posts on how to set this all up, but what we've tried to do, and I like Solomon's talk about it this morning, is we want to make things easy for you to do, right? We should do the hard work so you could focus on your work. So one of the things that we've done is we've created this scaffolder called YoDocker. So who's familiar with Yeoman? Okay, so it's a great tool for, it does a lot of things, but one of the things that we're using it for is to scaffold files into a project. And actually, let me come back to VS Code for a second. You notice that if I say new file, it's blank. We didn't ask you anything like which of 100 different templates would you might want to choose from. Because in Visual Studio, we support all of that. We've got great templating experience. VS Code, being an editor, we don't have any of that functionality. So that's why we are leveraging things like Yeoman to scaffold out those assets for you. So, and actually while I'm here, I probably should show off a couple of things. So here's our editor. That's great. We've got Git integration, which we'll show in a minute. I can switch branches. Notice that when I clicked the repo down here, it prompted me for commands. Likewise, if I open up a file, you can see that if I want to change some of the commands, the settings, that the command palette pops up. And that's because one of the things we're doing with code as an editor is we're focusing at command lines that you can run and stitch things together. As well as I could even change the language service, the editor that I'm using. And you can provide new ones. We actually ship a Docker language service with Visual Studio, Docker tools for Visual Studio Code. I'll have links at the end for that. And of course, you can tweet us little happies and frowns and let us know how it's going. That's really helpful, right? The Visual Studio Code team is very rapid on their changes that they make. Okay, so that's, oh, and there's one other thing. Wait, there's more. So they've also recently added a terminal window, so I could actually do my Docker commands right here in the window. Luckily, this screen's a little bit higher than it was in the keynote, so everybody could kind of see that a little bit better. So that's also some of the things that they're doing to kind of increase the productivity for us. Okay, back. I want to get those files into my project for how do I containerize my app. So if I use YoDocker, I can choose the language, and these are the 3 we support at this point. I'm going to choose Node.js. What port do I need? Because this turns out to be something that people kind of change. Image name. So I'm actually going to name it the image that I plan to deploy with as well. Web-node. and then the name of your service as it's defined in the compose file, and the name of your project that compose takes as well. So as a result, we've scaffolded out these files into my project, and I can see them right here. In fact, if I go to the Git differential, you can see them right there, that what we've done is first given you a Docker file, so you don't have to guess what that file should be. And we've got good language services here to help you understand, like you forgot the semicolon or the colon rather, or spaces and tabs. And that's just a straight Docker file. But in the debug mode, you'll see that we've added what we need to debug node. So it looks a little intimidating. There's a bunch of files there, but we're trying to provide the things that, as talking to developers actually using Docker, need. Next, we want to hook this stuff into Visual Studio Code. So if I look here in the VS Code directory, wow, this is big, sorry. We have a tasks.json file, and that's how Visual Studio Code hooks into functionality that I want to add. And if you notice, we have a build, a compose, and a compose for debug task. And then we call a script to set that up. And that's this bash script that we have here. And this is an interesting story about how we came to this as well. Originally, we had a publish feature in Visual Studio for Docker. And it was kind of cool, because you could take your existing apps and just publish it into a container. And that was awesome. Until people, like we left and we're all excited. Oh, they love that feature. We should do more of that. And then we got questions of, like, well, how do I work with different Docker machines? How do I use Compose? How do I use Vagrant? How do I configure this, and this? And we're like, whoa. Okay, lots of UI, lots of choices. And then we spent some time talking to developers that were actually using Docker in production already. So we went down to the San Francisco area and talked with a bunch of startups and found that they were all using scripts. So it's great that we've got the CLI, but nobody wants to type those commands each and every time. And they had a bunch of scripts that they were writing. So we curated a lot of those scripts and looked at the commands and figured out how can we tool that in a way that will provide that script for you, that we will scaffold it to start, but then you own it from there on, right? If you want to make changes, you don't need to have a feature request from us. In most cases, we hope, you'll be able to just edit it to your file. And if we see that's a common pattern, that we'll merge that in. We originally were starting with just Docker run. We evolved to Compose because we found that to be much more productive. So anyway, so we see those things happening in there. And there's the launch for the debugger. So that's kind of the most of what I wanted to cover there. Let's see if there's anything else I wanted to cover there. I think that was it. So, all right. Now, to debug Node, there's a two-step operation. One is we want to start the container, and we're going to use volume mapping, by the way, so that we can, if I look at the debug version, we're going to use volume mapping so that once the container is running, we can make changes and just use nodemon. You notice that nodemon was in there. So that I can actually just do the refresh. So what I'm going to do is start the command palette, and I'm going to launch one of those tasks that I had defined in my task.json in our batch script. Docker went away. Give that a second. Let Moby kind of spin itself up. There we go. And we'll do that again. Task, compose for debug. And now what we'll do is we're actually going to use that compose file. We're actually going to first build your image from the Docker file, and then we're going to compose it up, and it's already done there. And then we can launch the debugger, which will attach to that process. And one of the things that we're doing here is we actually use the attach with break option so that we can actually debug your startup code as well. It turns if you do an attach afterwards, it's great for page code, but what about your starting up of your environment? It's kind of nice to be able to debug that as well. So I'll step through that. And if we look here, localhost 3000, we can see there is our app. In fact, as we're making calls, we can see we're having a little bit of a problem here because it seems to be coming back undefined. Well, let's go take a look. Turns out that's the call here. So I'll set the breakpoint, and now I've triggered that. And if I look at it, I could see the body, yeah, it's undefined. But if I look at the error, I could see that, well, it's undefined because the API is not there. We didn't spin up any other containers. So here I get good debug visibility right here in our debugging tools. There's variables, there's watch. I could set conditional breakpoints. There's a lot of cool debugging capabilities here instead of console write. So how many people, that's the way they're debugging, is they're just spitting out to the console, yeah. So we're trying to make that better by letting you might do that, you might run a set of tasks, but when you have problems, rather than putting a whole bunch more of those statements in there, we want to give you the ability to debug into the container. All right, so actually I didn't mean to stop that. Let me show something else here. Let me actually start that up again because I want to show something about when it starts up here. Now I mentioned that we'll respin that so the containers are back up again. And when we start, as we step over the code, one of the things we're going to see is the API environment. There is an environment variable for API port and HTTP port, because that's how this app might be running or be configured externally. And we've set it up with default, so that's good. But we want to be able to expose that information and make sure that the next container configuring this has that. So this is one of the things that we want to test our code to make sure it runs in the container properly. And let's see if I just put the other breakpoint. Where did it go? Oh, mouse is backwards. We can see that as we step in, we see we're grabbing that as well. So if I come over to the compose file, we can actually set up additional environment variables for HTTP port equals 3000 and API port equals 5000. So now we're starting to have the ability to test that, and of course I can go and make changes. We'll make that 5001, 3001. Well, of course, you have to do the mapping on the port mapping of the container because the bottom one is telling Node what port to run on, and the top one here is telling Docker what do I expose publicly and what's internally running. So internally it's running 3001, and we'll just run, I don't know, 8080 here. So now I can go and test that. So we will stop this, and we'll run that again. Compose for debug. And if we've done it right, we'll see that when I start my debugger, and we'll just put a breakpoint here on the right after that. We'll get rid of that one. We'll just do it there. So now it did pick up 5001, so I know that I was able to externally configure this. And if we run it again, we'll see that, okay, 3000. Well, the trick is, does it really work? So we'll come back over here, and I think I said 8080. And yes, I do have it running. So I'm starting to make sure that my code is ready to be containerized as it gets rolled out, and of course, as it's run here. So that's all great. Okay, so that was step one, right? I got my web front end. That was built by my Node team. And now I've got this other API container that another team is developing. So let's take a look at what we'll do there. So I'll come over to this window here, and we'll open up this one. So here I've got a .NET Core project. And it's basically an API controller. We've got our startup. And here's our actual controller that I've got some interesting content in that we'll debug through. Now again, how do I do this? I want to run in a container. How about Docker again? So I can, again, get the assets that are specific to that language. So .NET Core, RC2, port 5000, and the image name, API.net. And now in my project, I've now got similar assets. I've got the Docker file that is our production release. So notice this is taking from our optimized .NET Core image and simply setting the entry point. And this is where you're starting to see some differences between languages like .NET and Go compared to like Node and Python. In .NET and Go, we want to precompile our app because we can get really good optimized DLLs so that I can make a smaller image and get my startup performance. I can get runtime performance, runtime density, and the .NET team is doing some pretty amazing work on performance in this space, and we've just begun to make some bigger impacts there. But in my debug version, I want to include the SDK. I want to include the debugger. I need to put some additional options on how I want to start this, because in development, we want to optimize for iteration speed. In production, I want to optimize for container start, container performance, container density. So we're thinking about those because unfortunately there are some trade-offs on that today. And if I look at VS Code directory, you'll see, again, we have the same commands for build, compose for debug, and the same bash script to stitch that up. Now, the only difference that we're doing here in .NET, and quite frankly, we want both scenarios, is here it's one command. We've got it hooked up so you hit the play button and we'll automatically build the image, compose, and attach the debugger in one step. So that's nice that I don't have to remember, what was that, Command P, task, whatever, to start it up. So it's nice that we get one experience. But what we're doing is we are composing each time. So we kind of want to be a little smarter about that unless if you've only changed the code, then we want to leave the container running and use volume mapping and just update your code in place. If you've changed your Docker file or your compose file, we want to be smart enough to say, all right, we're going to tear that down and respin it because that's the change you made. OK, so the thing you saw me do there was I had to change. Oh, the other thing we do in .NET here is we actually launch the browser for you. Because we own the whole startup process, we were able to launch the URL. We don't know what URL you want because we scaffolded in generic stuff, but that's OK. You can actually go and make that change and launch JSON. There it is, launch browser. API /hello. And if I restart that, in fact, I'm going to make a little change here. So we will say hello from Docker Con API.NET container. Now here, when I restart my session, notice how fast this is spinning up, right? We are caching image layers. We've done some work in the Docker files. And that fast, we were able to rebuild the image, compile the DLLs, and then launch it again. And now my API just launched because I put that as a start URL. And we've got our little DockerCon text in there. And I don't think I did the breakpoint yet. Of course, we actually get breakpoints in here as well. So when we refresh, we can now step through and see that although I'm running on a Mac, the code is actually running in my Linux Docker image. So that's some of the stuff we've got going on there. Let's see how we're doing on time. OK. All right, great. So now we've got the two teams that have been working separately, right? You've got the web front-end team. You've got the API team. And the thing that's interesting here is it's not that they're using two different languages, and that's why they're in two different teams. It's because they're in two different teams that have different leads and different interests that they've chosen the stack that they want. And that's one of the great things around microservices and Docker containers is you get this great isolation. Right? I could be using, from a .NET developer, I could be using RC1 in one container, RC2 in another, and some ASP.NET that we, from full framework in another container, and it all runs on the same machine. Right? And or I can have different stacks. I could, just be using completely different stacks side by side, as long as their public communications are interoperable, REST. Then you're good to go. Let each team have its own preference. But the other side of it is, here I'm developing the .NET stuff. How do I test this? Now, I can write test scripts. I can do Postman, and I can run some automation. I'd probably run automation in another container and spin that up and test this, because I really don't want to put my test code in my container, because I'm really not testing the thing I'm shipping, right? I really want to test it externally. So this is where these additional files that seem a little bit much at first start to pay off. So what we're going to do is pull up our compose file for debug here, and I'm going to define another service. I'm going to actually grab in the web node service, and I'm going to reference it by the image, because as the .NET team, I don't want to figure out and have the right node environment to set this up. And the node team doesn't want to deal with .NET, right? Or whatever it is. That's the whole point of containers. I want to test what they've built. I don't want to recompile their code. So I'll do, web node. And I'm going to grab the latest, because I don't want to grab just some development image. And of course, I need to set up the ports. And the ports in this case is, 8001 and 3000 in the container, unless I change the environment, which of course I can do. And I'll do it this way. HTTP port is 3000 equals 3. And API port equals 5,000. Of course, I could change this as well. So I think that's all I need, yes. All right, so now I've actually defined my environment, how I want to go and run this. So now I can, because I'm in the .NET case, I can actually just start this, and it's going to collide because, invalid. What did I mess up here? Environment, port, image, web node. Ports, thank you. There we go. Why did it give me coloring for one? OK, that shouldn't have done that. At least it gave me the IntelliSense. Group debugging, love it. OK, so it'll now spin up both of those for me. And actually, in this case, it's pulling the latest, because I apparently didn't have it on this machine already. I didn't pre-cache it. So which is perfect, right? I don't want to grab some random when I really want to grab the one that my team has published for me. And networking is working, so we'll pull that out. And now it'll spin it up, and it's running. I could see that it's spun up. My debugger is hooked. It launched the page. It hit my breakpoint. But it actually, if you notice, it went into the web API, because that's the launch URL I told it. Was it 8,000? It's the problem with keep on changing it. Hold on a second. What did I tell it? 8001. I think I'm only proving to myself that I'm actually doing it different each time. All right, so where was I? 8001. Oh, hold on. There we go. OK. So there's my web front end. And if I make the API call, now it's in that controller. And now I can step over my code. And was an interesting example. So we were talking with some customers around why they would debug, why they needed to debug in their container versus running it on the host, especially on languages like Node and .NET, which we have these frameworks that do a great job of abstracting out the OS. And that is that the OSs themselves has some subtle differences. Turns out there's a reason why there's different OSs in the world. And in this case, they were bit by time zones by IDs, is apparently people had different implementations of what that would be. So and this API actually throws an exception because it didn't find what it wants. As opposed, in addition to things like file paths and case sensitivity and some other problems that people often have. So there we go. We are now testing that. And of course, we could change our launch to be the root of our HTTP localhost. And if we restart that again, now we could set up that our repeated debugging environment will just launch directly into that URL. If I didn't do, what did I do wrong? HTTP localhost args. Did I mess up my compose file again? Oh, somehow I fat-fingered something. Okay, let's try that again. So, always interesting to try to get stuff from normally an hour 15 session into 40 minutes. So let's see how we're doing here. We're doing pretty good. And, oh, it's right. I forgot to change it to 8001. So fine. You know I can type and restart again. And hit my debugger. And there's, you can actually you can keep your breakpoints and just disable them down here. I'm disabling individual code files as well. So now as I'm repeating that, we see that's gone. Okay, so I got my inner loop done. I'm pretty happy with how that worked, but I am so far developing in my test environment, my debug images. I do want to test my release mode as well. And this is where our Docker task comes in helpful as well. What I can do, let's go take a look at, I'll do it up here. Docker images. And I have a couple of broken ones here. But if we look closely, we can see that our API.NET, our debug version, it's kind of big. And that's because it has our SDK, and it has our debugger, and it has so much of other stuff. And there's a bunch of extra NuGet packages in there that we haven't finished cleaning up as well. Turns out we didn't realize that the DLLs were already on disk because we have a shared framework. So helpful to put them there again. We have a change that's coming that will actually realize what's already on the machine and only put what you need. And then our web node image, there's 677. Now I want to get my production image. So what I'm going to do here is I'm going to say Docker task build release. So I want to get the release version of that image because that's what my CI system is going to test. Is going to build in the CI and CD solution. And now if I look at my images, we're going to see a latest API.NET. Where's my API.NET latest? Oh, I'm in the wrong one. I'm sorry. I was trying to use the top window so you could see better, but I was in the wrong project. So let me try that again. I just have to type it. /docker task build release. So that was the release image of my node project. This is going to be the release image of my my .NET project. And this we could do up here. And here it is. Now we've got it down to a nice slim 247. We actually think we can do much better than that as well. But now I've got a nice condensed image, no extra payload in that. Well, there's a little extra where we have more to trim, but certainly less than my SDK. So that's all cool. I think at this point, I could show how we could spin these up with compose and so forth, but I really want to spend some time in our CI system. But I can certainly do a Docker compose. Let's see if I actually already put it in here. What I'm going to do is we're going to switch to the release mode. I'm just going to go and grab this other branch. Oh, that's right. I got to clear this out. So there's our Git integration, but I'm going to actually clear out those changes and change branches back to master where I already have those files in there. And if you look at my compose file here, you'll notice that I actually already have both of them set up. So just a nice way to reset here just from a demo assurity, my own demo gods. So what I'm going to do is now I've restarted those two, and now we're on port 80. So now if I go and test this, I'm now testing my app, and notice I am getting my APIs called as well. So this is the code I'm about to push into production. So I'm testing everything that I've just changed. And in fact, we'll make one more change. Let's just make some change in here to prove we're doing something we're going to deploy. Not there. There. Hello from, give me a number. 42, all right. Okay, so we've got that. If we notice, we have a single change. We just go and did the retest. Okay, you're going to trust me on this one. And I'm going to say, all right, the answer is, if I could spell answer. And we'll commit that. We're going to, actually, I'm not going to sync that yet because it happens a little too fast. As I do my commit, and in this case, I'm committing to GitHub, we have Visual Studio Teams services here. And here, we've got a full view of how my code can be managed. And I've got this demo that I've set up here. And we'll just go into full screen mode here. And you can see we've got a dashboard for managing work and collaborating on code and CI. And we can actually see the progress that we've been doing across these projects that I've customized this dashboard. And you can see I usually am messing with the web node, although I just did a change here, we'll see. And then I've got this other project that I use for deploy. And the model is I have these two separate teams that are building their containers individually. They have their own source code, their own repo, and they want those to be tested individually. They want to be tested collaboratively too, but they are working isolated. It's kind of one of the models of microservices. And I don't want to get into the definition of microservice per se, but because my personal view is we're talking to customers and seeing this is a microservice can be a collection of containers, but it's a defined unit. It might be the database, it might be the cache and the API, and that thing gets deployed as one unit. But the app is this collection of collections, and it might be containers and it might be PaaS services, as you will. But individually, these things get built, but I have one compose file that I'm using to define how they all interact with each other. So as I look at this, and we'll look at the web node, we can see the build definition. And what you're seeing here is in VSTS, we have some Docker build steps where we can first do the Docker build, and that's not too bad for visibility. And I can see that, and I actually do a build, and you can see the build number. We had a build number out of VSTS. And then I'm going to push that build number to my registry. And then I'm going to do a bunch of tests. And these tests will actually perform really well because they're disabled. Who has tests that are like this? Yeah. So, OK, 40-minute session, only have so much time. Then we'll tag it, assuming it succeeded, which looks like there's a good chance that these will succeed in this case. I'll tag it latest, and then push to the registry, and that's our latest image. And then we're going to do a common deploy, because I have individual projects, but I have one deploy. If I look at the API, because this is .NET, it could have been Go, similar thing. I first want to compile my app, which in this case, I first need to restore my packages. And I'm not doing this in my end container, because my end container shouldn't have the stuff it takes to restore and do all of the other things it needs to build an image. I really want just my compiled binaries. So I'll restore NuGet packages. I'll compile the code and publish. Publish says, go get all of the binaries and static content that you've defined that should be deployed, not the debugger symbols, not the other GU XML files used for IntelliSense, just the things I need to run. And then when I do my Docker build from that context, I can pull in just what I need to this image that knows how to run code. It doesn't know how to compile code, right? It's very streamlined. And then I pick up the same steps, including the same depth test analysis. And we'll test pass, right? Because they're disabled. And we'll tag latest, push the latest, and trigger a deploy, which is this build step, which you can see runs another set of very depth testing. See, I've got lots of intent here. And then the deploy script, which will call out and shell into SSH into my environment, and then call compose up. So let's do a quick check-in here. We'll do a sync. And when we'll go back over to here, we'll see a queued build. Which one did I push? Oh, right, it was the other one. I changed my demo. My API, So if I go into here, I can see the build happening. Now, by the way, this is actually a Linux build agent. It's not a Windows build agent trying to do Linux. And it's not even Windows using the Windows subsystem for Linux, which I apologize. I intended to demo today, but you can see the colorful scripts there. I can put a different logo on my laptop. But it's a Linux build agent because that's my target environment. So this is where we've been doing a lot of work with Visual Studio Team Systems to support all languages. Because Azure, we want to be able to run all of your workloads, not just .NET and Windows, right? We have a really good commitment across the entire board. So that was succeeded. And if we look over here, we can see deploy is queued. And now that's running to go and pick up those changes. And we'll deploy out the change that I had. So we'll let that run there, and that would be good to go. Let's see. We'll let that finish up there. It's doing the compose. What else did I want to cover? Show the optimized images. Workflow. We're actually in pretty good shape. OK. Anyway, so so we're doing, I'm not actually doing the most optimal thing there. We can actually do some better work there on how we deploy this. What else did I want to cover? I think that was mostly about it. We'll let that run for a moment. I'll pop out over here. Ooh, that'll be weird. We'll let that finish. There we go. It's almost done. So it's spinning that back up again, and now we'll have our change there in a moment. If we look at, there's our production site. And I forgot what I changed. We said something about 42 in here, I believe. Any quick questions? Well, instead of me doing a dance, because you don't want to see me dance. Yeah, the slides will be, I'll show you the links at the end. They're on my GitHub account. OK, so that's succeeded. And the answer is my project got deployed. Did it get deployed? There we go. And is there a 42 in there? There is. So we have success. So we could hit that a bunch of times. I'm not going to hit it 42 times because you guys want to get out of here. So let's try to get this running again. We'll do the magic thing. And so we've got, in that approximate 40 minutes, we've walked through that entire workflow for you can do a multi-container development. You can do it as one team or multiple teams. You can actually instance multiple containers in your development mode because that's the idea of microservices. I know we don't necessarily want to test the entire 500 containers at one time, but you're probably going to want to test more than one. So we wanted to provide some tooling to help you out with getting you started. From what we hope to offer you, and of course, we would love to provide more functionality as you need it. On the client, we've got Visual Studio Code on both Mac and Windows, a very lightweight editor, as you saw, with some rich integrations. We also have Visual Studio on Windows, which we do a lot of great work there as well. We've been doing a lot of work with Visual Studio, Docker tools for Visual Studio as well, and we're looking at deploying and debugging multiple containers. Visual Studio Team Systems with Git and Jenkins integration, of course, with the Docker build tasks. We have Linux build agents in addition to Windows build agents now. And the Azure Container Service with Swarm, so you can deploy out into production, as we talked about with private registry and so forth. So with that, I will wrap up with a bunch of links and some called out to some other sessions. The Windows guys are going to drill into some of the stuff they're doing with Windows containers. They're doing some awesome work. And we will follow up with our tooling with Windows containers later this summer as we get to the Ignite conference. There's, in the keynote tomorrow morning, Mark's going to do some demos there, so that'll be cool. And then Ross will be talking about the Azure Container Service tomorrow afternoon. And for the tools that I was showing today, so first of all, on azure.com/tools, you can see the stuff we have for both Azure and our Docker tools. The links you see there. The command line stuff I did was Docker. We had Visual Studio tools for VS, VS Code, VSTS, blah, blah, blah. I guess you can all look at all of that, and I will wrap up and take some questions. And I thank you for coming and having us here. We're really happy to be partnered with Docker and helping developers build their apps and get them deployed. So thank you.